And what I would like to do today is, or this time, is to put the second part into it. Last part I talked about star motion, which is what's called prograde motion, which is basically coming up from the east and going down in the west. We talked about circumpolar constellations, equatorial constellations, and a few other facts. This time what we're going to do is we're still going to use astronomy department at the University of Nebraska, Lincoln. We're going to go down to their simulations, and from the simulations I'm going to pick this one. This is what's called a geocentric view, and what that means is the Earth is the center. And if you actually think about it, this is pretty much what people would decide, because in most cases on this planet we never feel the Earth move, even though here in Virginia we're moving at about 700 miles an hour around the planet as it rotates. 30 miles a second as it revolves. Sun's moving at an exponentially fast speed around the Milky Way, and the Milky Way is actually moving at a large speed. So we've got all this motion, but as long as it continues at the same speed in the same direction or same relative direction, we'll never notice it. From this one you can actually pick different planets. You can pick the epicycle size, which is what this is called. And when ancients actually imagine themselves sitting on this stationary flat Earth and watching what these stars did, or these planets, which is what they called these wandering stars, which is Mercury, Venus, Mars, Jupiter, and Saturn, the only planets they could see with their naked eye. They had to come up with some different terminologies because they didn't move the same direction as the stars. They didn't move in this nice, beautiful, constant motion year after year, day after day, hour after hour. It just didn't do this. So they had to come up with something called the deferent. Deferent is the seeming orbit that goes around the Earth. They had to come up with what's called the epicycle to explain what kind of motions they had. And this would normally be Venus's orbit, moving in a counterclockwise direction, but they saw Venus do something really strange against the starry background that you can see here. So they had to come up with this epicycle, and you can actually change the size. This is the size of Venus's AU value. So that's the size of its epicycle, and they actually were able to figure that. It is an inferior planet, which means it's closer to the Sun than we are. You can actually make it a superior planet, which is like Mars and out. This one would be Mercury and Venus, so it actually defaults that. If you actually pick a different planet like Jupiter and you click OK, see it flips to a superior planet. But I want to show you Venus first. So click OK, and we're back where we're supposed to go. You can adjust all this stuff if you want to, but this is the way Venus is supposed to go. Motion speed seems like a really good speed. You can slow it down or speed it up if you want to, but I'm going to try to keep it right there. Apogee angle, this actually talks about how round this thing is. That's the same thing as eccentricity. If you slide this to 0, it's a perfectly round. If you move it over to this, and some of these planets have much larger eccentricities than 0.2, you can see it actually moves the Earth out of the center. But I'm going to move it back to, whoops, wrong one. This is 7.2. Actually, I'm just going to click OK, and it moves everything back where it's supposed to go. And all you have to do is click Start Animation. And I actually have it showing path durations. I want it much longer. What that's going to do is it shows that the normal motion, then it backs up, reverses, and then goes back on its merry way. And while this is showing, I want to go over and show you this site. This one. This is what Mars actually does. And if you take a look at it, it moves from October 2nd to the 7th to the 13th. The planets, because the Earth is moving this way around the Sun, it makes all the things look like it shifts this direction, which is called prograde motion. So if you looked at this at 8 o'clock tonight and you looked at it at 8 o'clock tomorrow night, it would shift over. And these things actually are doing prograde motion. They're moving in the same direction. They do move at different speeds. That posed questions for the ancients, but because it was moving in the same direction, they still called this prograde motion, normal motion. But if you take a look at it, it seems to slow down between the time periods, and then it reverses and goes back the other direction, which is called retrograde motion. And it does that speeding up, then it slows down, stops again, and then goes prograde, speeding up, and which it does that most of the year. Now this would actually be called a retrograde of Mars in the constellation Cancer. Next time it may actually go in Virgo, which is the one next to Leo. Last time it was probably in Gemini. The other one on the other side of that is Taurus. Would have been a Taurus one, so it seems to skip about each and every time. Okay, so let me go back to this one, and you can see it's actually making this sort of star-shaped. If you drew a star there, and let me show you what that looks like. Here's Venus's, and 1, 2, 3, 4, and 5, exactly like it's showing you here. So this is what's called a geocentric, and this is how it explained these retrograde motions that we see. Really complex. If I pause this animation, if I restart the animation, the easiest way to do that is just to hit refresh. If you actually think about its motion, they had to do a really complicated setup here, because what would actually cause Venus to go around the Earth and then also go around this other cycle, getting closer, in fact sometimes even closer to the Earth, which you'd think would come flying into us. But this is the way they explained this motion, and if you take a look at it, sun goes that way, planet goes this way, planet backs up. There's the retrograde motion. Here it comes again, going the same direction, and slows down in Aries, retrograde motion. And here it comes again. Should actually go right around here. And there's the retrograde motion. You can see sometimes it retrogrades even more than it does other times. I'll let that one stop. And this is what we believe today. This is called a heliocentric, a sun-centered. And presets, let's go to Venus again, 0.72 AUs. We can actually make Venus farther away if we want, but we're going to keep it at 0.72. Okay, then we can do the speed. I do need to talk about a couple other things. This is called inferior conjunction, where it actually is, if you take a look at it, it's actually inside. The angle of the sun and the Earth, it's inside, but it's on that same angle. Here's what it would look like if we're looking at it. So we would be looking at it in there. So let's go ahead and do the start animation, and then it goes to greatest elongation. It goes to super conjunction when they're exactly opposite each other, and then it goes to greatest elongation. And then it goes to inferior conjunction again, where it gets in between us and the sun. Then it goes to greatest elongation, and then it goes to superior conjunction. It just keeps doing that. And if you watch this side, you can see it's moving in a prograde. And then as we actually catch up to, Venus catches up to us and passes us, it backs up. So they were actually seeing the same thing with this model as they saw with this model, but this model actually, to make this work the way it's supposed to work, they put it on this epicycle, and this one's a nice clean orbit, just retrograded again, and that's the way it works. Okay, thank you much. Bye. Prograde, retrograde. Prograde normal motion, retrograde the reverse, and you can look at it the geocentric, which is also called the Ptolemaic system, or you can go to this one, which should actually be the Copernican simulator, because he's the guy that actually comes up with the whole idea of the sun-centered, the heliocentric, versus what the ancients, Aristotle usually is given some credit for this, talking about the earth-centered, the geocentric. Okay, that'll stop it. Take care. Bye.